Good morning dear students, this is Bonani Porokasto. I welcome you all to today's video. Here we are doing the chapter Determinants. Example 26. Show that the matrix A satisfies the equation A square minus 4A plus I is equal to O, where I is 2 by 2 identity matrix and O is 2 by 2 zero matrix. Using this equation, find A inverse. So first of all, we have to show that this matrix satisfies this equation. After that, using this equation, we have to find A inverse. So here we cannot use the formula of A inverse, which is 1 by determinant A into adjoint A. We have to use this equation to find A inverse. So for this, first of all, we have to find A square. So here is the A square, matrix A into matrix A. So the A square is this matrix. Now in place of A square, we have written this matrix and minus 4A means the matrix A is multiplied by 4. So if it is multiplied by 4, then every element of A will be multiplied by 4. So 4A is this matrix plus I. So I is the identity matrix, which is a 2 by 2 matrix. Now O is the zero matrix and it is also a 2 by 2 matrix. Now if we calculate this part, then we will get 7 minus 8 plus 1, taking this 7, 8 and 1. So from here we will get 0, this 0. Then 12 minus 12 plus 0, from here also we will get 0, this 0. Then 4 minus 4 plus 0, this 4, 4, 0. From here also we will get 0. Then 7 minus 8 plus 1. So from here also we will get 0. So from left hand side we will get all zeros. So this is a zero matrix which is denoted by O. Now we will find A inverse from this equation. So for that we have taken identity matrix I to the right hand side. So it will become minus I. Now we will multiply both sides of the equation with the A inverse and we will do post multiplication. So here we have written A inverse, here also we have written A inverse, here also we have written A inverse. So from here we will get A into A inverse means A into identity matrix I. From here also we will get 4I and minus I into A inverse is equal to minus A inverse. So from here we will get AI minus 4I is equal to minus A inverse. So from here we can write it as A inverse is equal to 4I minus A. So now we will put the matrix I and matrix A. If we multiply matrix I by 4, it will become like this minus the matrix A. So from here we will get A inverse is equal to this matrix. So in this way we can solve this kind of questions. Question number 14 of exercise 4.5. Here this matrix is given and we have to find A and B such that this equation is satisfied. So for that we have to find A square first. So here we have written A into A. So for that we have to multiply the first row with the first column. So it will become 9 plus 2. First row into second column. So it will become 6 plus 2, 3 plus 1 and 2 plus 1. From here we will get 11, 8, 4 and 3. Now we will put the matrix A square in place of A square in the equation. Then we have to put the matrix A and the matrix I and the matrix O. O is the zero matrix. Since here our question is given a 2 by 2 matrix, so we have to take the identity matrix I and the zero matrix O, both are of order 2 by 2. So after that we have to multiply each element of A by this A and each element of I by B. Now we have to add these 3 matrices on the left hand side. So it will be 11 plus 3a plus b, now 8 plus 2a plus 0, then 4 plus a plus 0, then 3 plus a plus b is equal to the 0 matrix. Now if 2 matrices are equal, then they are of same order and the corresponding elements are also be equal. So from here we can write 11 plus 3a plus b is equal to 0, 8 plus 2a is equal to 0. From here we will get a is equal to minus 4. We can put the value of a in this equation, and from here we can find b is equal to 1. So value of a is minus 4 and value of b is 1. Question number 17, here the question is given, let A be a non-singular square matrix of order 3 by 3. Non-singular means determinant of A is not equal to 0. Then determinant of adjoint A is equal to 4 options are given. We have to find determinant of adjoint A is equal to what? We know A into adjoint A is equal to adjoint A into A is equal to determinant A into I. Now here it is given A is a square matrix of order 3 by 3. Now first of all we will find determinant A into I. Since A is a square matrix of order 3 by 3, we will consider I as a 3 by 3 matrix. So determinant A into I will be determinant A into this matrix. So every element of this matrix will be multiplied by determinant of A. So it will become like this. Now let us write adjoint A into A is equal to determinant A into I. From here only we can write this. Now we will take determinant on the both sides. So if we take determinant like this, then from here, from every row we can take determinant A outside. So it will become determinant A cube, as from row 1 we can take out determinant A, from row 2 we can take out determinant A, and from row 3 also we can take out determinant A. So the determinant will become like this, and we can separate these two. Now if we expand this determinant along row 1 or every row or every column, you will get the answer 1. So from here we will get determinant of adjoint A into determinant A is equal to determinant A cube. From here we can cancel out determinant A, so determinant of adjoint A is equal to determinant A square. So the answer will be option B. Question number 18, if A is an invertible matrix means A inverse exists, of order 2, then determinant A inverse is equal to, 4 options are given, we have to find determinant A inverse. We know A inverse is equal to 1 by determinant A into adjoint A. So let us assume that A is a matrix of order 2 by 2 and the elements are A, B, C, D. Now determinant of A will be AD minus BC. Adjoint A will be transpose of, now see here D is the cofactor of A, minus C is the cofactor of B, minus B is the cofactor of C, and A is the cofactor of D. Now we will take the transpose of this matrix, then it will become D minus B minus C A. Now we will put this in place of adjoint A. If we put this in place of adjoint A, then after multiplying it by 1 by determinant A, the matrix will become like this, because every element of this matrix will be multiplied by 1 by determinant A. Now if we take determinant on both the sides, then from row 1 and column 1 we can take out 1 by determinant A, then outside it will become 1 by determinant A square, and the determinant will become like this. Now we can do it like dA minus CB. So this is determinant A. From here we can cancel out determinant A, then it will become 1 by determinant A. So determinant of A inverse is equal to 1 by determinant A. So the answer will be option B.